So here, especially I would like to discuss this C part of this question. So what is our question? Find the probability that a randomly chosen arrangement of the 8 letters in the word has all 3 O's together, given that the 2 C's are next to each other. So the key word we need to be very careful is about this given that. So what is our aim? Our aim is to find the probability that a randomly chosen arrangement of the 8 letters. So altogether we have 8 letters with us. So these 8 letters are COCOONED, correct? So here how many C's are there? We have 3 C's, 1, 2, not 3 C's, I mean 2 C's, we have 2 C's, and we have 3 O's. And then apart from that, we have these 3 letters NED. Am I right? Okay. So now, what is our aim? Our aim is to find the probability that all 3 O's together, given that 2 C's are next to each other. So, probability of getting 3 O's together, given that. So what is the meaning of given that? This is a conditional probability question. So 3 O's given that 2 C are next to each other. So for the sake of this convenience, this 3 O's, I'm just writing it as 3 O. 2 C, I'm just considering it as just 2 and C. Okay. So the question is to find what is the probability of 3O 2 given that it is 2C. We know an idea about the conditional probability, correct? Suppose if you're considering 2 events, say C and D. And if you want to find what is the probability of C given D, so how we will find this probability of C given D? The probability of C given D means it is probability of C intersection D divided by probability of D. So this is the idea, correct? So here, if you're just considering the situation, in place of C, we have this 3O, and in place of D, we have 2C. So the probability of 3O given 2C means it is nothing but probability of, it is nothing but it is probability of what? So it is probability of 3O intersection 2C divided by probability of getting 2C. So what is the meaning of 3O intersection 2C? It means that what? We need the total number of, because we need the probability. So we will just write the definition of probability of 3O intersection 2C here. So what that means? It means the number of arrangements that gives what? 3O and 2C together divided by the total number of arrangements for these 8 letters. Am I right? So how we will find this total number of 3 O's and 2 C together? We will just write, or we'll just draw that situation here. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 letters we have 8 spaces to fill. So what is the condition given in our question? It means that somewhere we need to fix, whatever be the case, 3O will be standing together. And apart from that, this 2C will be also standing together, correct? So 2C will be also, because that is the condition given, right? See, 3O and 2C, that must be the case, correct? So 3O, we will be considering it as a one single unit. 2C, we will be considering it as a second single unit. Then rest of these places we have, because you see this 3 O's already we fixed it. 2C, we already fixed it. Then we have 3 letters with us, NED. So this NED, we can place in these places, 3, 4, and 5. So how many ways we can do this? How many ways we can do this? So this we can do in 5 factorial ways. So the arrangements that will give this number of 3O and 2C, we got it as 5 factorial ways. Clear? 5 factorial ways. Fine. Now, we are not interested in the finding the total number of possible arrangements. If you want to find the total number of possible arrangements, we already calculated the total number of different arrangements of the 8 letters in the word. We already calculated. So if you want, you can take that answer from part A. Okay, so that's the total number of total number of arrangements. Okay, fine. So this is the case for the numerator. Then what is the probability of? Then we will see the probability of finding arranging 2C together, because here this numerator part we got. Now we are interested in the denominator part. So what is the probability of getting 2C? So what is the answer? Total number of arrangements that gives 2C standing together divided by total number of possibilities. So total number of 2C. So we have 8 spaces together, right? So 1, 2, 3, 4, 5, 6, 7, and 8. So out of these 8 spaces, we are fixing what? 2 C's, because that is standing as a single unit. So this is 1, 2, 3, 4, 5, 6, 7. So we have 7 letters. Okay, so in this particular arrangement, we have 7 letters. Why? Because 2C, we are considering it as a single unit. And out of this 7, we know 3 O's, right? So these 3 O's, either it may be present here, or present here. So whatever be the case, we have 3 O's in, we need to fill in the what? The other positions, or in these 7 positions. So how will you find it? The total number of 2C, that is 7 factorial divided by 3 factorial, because this 3O is repeating thrice, right? Or 3 O's are there. So that is why, to avoid that stuff, we are dividing that it with the 3 facts. So 7 factorial by 3 factorial divided by total number of arrangements. The total number of arrangements divided by total number of arrangements. So now we will substitute all these stuffs in our formula. So the question is to find what is the probability of getting 3 O's given that it is 2C. So what was the formula? Probability of 3O intersection 2C divided by probability of 2C. Am I right? So what is that formula? That is 5 factorial divided by total number of arrangements divided by 7 factorial by 3 factorial divided by total number of arrangements. So this got cancelled off, and what we are getting? We are getting 5 factorial by 7 factorial by 3 factorial. So if you are simplifying, we will get it as 1/7. Hope this explanation serve the purpose for this C part. So this question is June 2023, 5-1. Question number 2. We specifically discussed about question C. Okay.